Well, it's 9 o'clock, so let's get started. How was everyone's, whatever it was, weekend? That word? Good, good. Did y'all do your homework? Good job. I didn't do any of mine yet. If y'all tried to go to my office hours on Friday, I wasn't here. Sorry, I had a root canal. So if I start to talk funny, that's why. Have any of y'all had a root canal before? It's not fun. So, y'all probably got my long email about your homework stuff. So, when I mean that someone isn't paired into Canvas, it shows this thing right here. So it says unpaired student. There's only like 4 of you that are unpaired. And what it means is I have to manually enter your grade into Canvas. So, if it shows this in my grade book, I will probably email you and have you sign in to Alex through Canvas. Then it will link your account to your Canvas account. Because I don't want to have to go and manually put in grades. I did that last semester, but it was only for 1 student, so I didn't worry about it. But there's like 4 of you, so I'll email whoever it is that has that. So, as you know, your homework is due, I think, Thursday at 11:59. That sound right to everyone? Cool. So, Chapter 2 homework, it does show a due date, but I'll probably move it back depending on how much we finish today. I also printed off some of the Chapter 2 homework. If you want to get started on it, we'll go through what you'll see on it compared to what we're doing in class. It's going to be pretty much the same, except the way Alex is, it's very picky when you graph stuff. And I don't know why. So, that'll be fun. So, does anyone remember anything we did last time? Talked about the range, class width, stuff like that, and using that to construct frequency distributions. Okay, cool. Everyone online, can you hear me? Cool. Okay, so last time we looked at the data below, which was record high temperatures for 20 states, and then we want to create a frequency distribution. So, using the rules on the previous page, or whatever page it was. God, these things are long. Where is it? Yep, on the previous page right here. We want to follow these kind of guidelines here and construct a frequency distribution. So, first thing we did was calculate the range. Yes, we did that. We just took the highest number minus the lowest number, and that's the range. So, next, determine the number of classes, which is always given to you, which I told you, 8. And then you want to calculate the class width. So the class width was equal to the range over the number of classes that I asked for. And then we said if the class width ends up being a decimal, always round up to the next whole number. So that's pretty much where we got to. So we're going to go over this again because I see a lot of students kind of mess it up. So if you did it that way on an exam, like some of you last time, you had the class limits from 101 to 105. So I probably wouldn't have taken anything off, but the way we calculate class limits, we take the lower limit of the first class, then we add the class width of that to get the lower limit for the next class. Does that make sense? Then we subtract off 1 to get the upper limit for the previous one. So, if you mess that up on an exam, if I put anything on there, I will probably, if anything, count off like a point or something. I'm not that mean. Okay, so last time we started finding these class limits. So, we had 101 plus 4 equals 105, subtract off 1, and we kept doing that. So now we're at 113, and to find the next lower limit, we go plus 4 is 117, minus 1 will get us the other upper one, which is 116. Why are there so many freaking classes? 121 will be the next lower limit. So then if I subtract 1, the previous upper limit will be 120. Similarly, if I keep doing that, then you should end up with this. That. Does everyone agree? Or does everyone see how I did that? Okay. I got a head nod. Anyone else? Okay, cool. So the next thing you want to do is find the class boundaries. So last time we said the class boundaries can be computed by taking 0.5 off of the lower limit of our class and then adding 0.5 to the upper limit. Does everyone remember that? Okay, cool. So if we do that, we end up with 100.5 to 104.5, 104.5 to 108.5. Does anyone know why we subtract and add 0.5 to it? I think I told you all that last time. Because when you're constructing a histogram, which is what we do here shortly, I think, you want these bars to touch. So notice how they have in common 104.5. That means the bars are going to touch at 104.5. So that's why. So does this seem like something y'all could do if I asked you on an exam? Okay, cool. You're going to be asked to do it on your homework, I'm pretty sure. Last semester, I didn't make them compute this whole thing. I just asked a question. I said, here's a class, find the width, the boundaries, and that was it. So, and then I made them draw a histogram, but I gave them everything already, so. I'm pretty nice, I guess, on exams, except the final exam. The grades were not good last semester. It was like a 60%. Does anyone know if we have to take them online again? I really hope we don't have to. I hated that. One of the other instructors said we're supposed to do it through Examity again, and that was a pain. Oops, I can't add. That should be 124.5. Okay, so did everyone get that? People online, you get what I'm doing? Yes, no, maybe? Cool beans. Okay, so next we want to find the frequency. So obviously the frequency is the number of data points in this data set up here of temperatures that fall within these class limits. So does that make sense? So for the class limits of 101 to 104, we want to see how many temperatures fall within 101 to 104 up here. So let's do that. So obviously, since we're starting our data set at 101, we do have 1 point, which is 101, and then we also have a 103. So the frequency for that class is 2. That is an ugly 2, sorry. So does that make sense? We're going to go slow. That way we don't mess up. So then for 105 to 108, we want to see how many values fall within there. So we have 105 there, 105 there, that makes 2, a 106, a 106 again, a 107, 108. So that was 1, 2, 3, 4, 5, 6. So then you do the same, 109 to 112. So you have 110, there's 1, 111, there's 1, and that's it. So for 113 to 116, so we have a 113 right here, a 114 right there, a 114 right there, and a 116 right there. So that's 4. So 117 to 120, so 120, that's 1, 118, that's 2, 119, that's 3, and 117, and that's 4. Okay, 121 to 124, there's only one data point left, or two data points left, and it's not that width, so 121 to 124 is 0, the frequency is 0, because no data points fall within there. Makes sense? Cool. 125 to 128, so we have 126 and 128, so that's 2, and then that's all the data points. So if you even look up there, you'll notice that there's no data points within 129 to 132. So that's how you create a frequency distribution. So one question I think some other instructors ask is a valid frequency distribution, and all you have to do is make sure that the total frequency matches up with the given total. Also, you have to make sure the class widths are equal. Makes sense. And also that all the data points are included in the frequency distribution. I don't know what I'll ask you yet. So, is everyone okay with that? I hate when this light goes off. There we go. What the? So, what else can we find besides frequency? And most of you have probably heard of relative frequency. Am I right? Anyone? So, relative frequency is, so I put, this can be found by taking the frequency of one class and what do you think? If we want to find a percentage of data points that fall within a certain class, what do you think we're going to divide by? Total number of data points, that's what it is. Does that make sense? So, relative frequency is basically a percentage of data points that fall within some class. That's what it is. So, there's also something else we can find, but I don't know if we talked about it yet. Let's see. Yep, it is the next one. So, is everyone okay with that? You think you could find that? So, what is the relative frequency of that class? First one. So, we have the frequency of this class is 2, and the total number of data points is 20 up there. So, the relative frequency would be 2 over 20, or 0.1. Is that okay with everyone? Okay. Sorry, I'm getting a question on the chat. I'm getting 2 questions. So we only add the numbers. Page, yes. So if I ask for like the relative frequency of any given class is the frequency of that class divided by the total number of data points. So it says 20, so you divide by 20. Does that make sense? I guess so. So now that we've done that, so the next thing we could talk about is cumulative frequency. So does anyone know what cumulative means? Cumulative means like building on itself. So if cumulative means building on itself, cumulative frequency means we're going to keep adding up the number of data points in the preceding one, which will make sense whenever I show you. So sometimes it is necessary to use the cumulative frequency distribution. So the cumulative frequency can be found by adding the relative frequency of the class below to a frequency of the given class. So this should be, I guess, yeah, it is cumulative frequency, never mind. So cumulative frequencies are used to show how many data values are accumulated up to and including a specific class. Accumulated up to, remember that. So using the same method, you could also calculate the cumulative relative frequency if I asked. So from this right here, oopsies, not that, nope, not Microsoft Teams. So first thing we want to do is find the total frequency, and then we can find the relative frequency of all of these, and then we can find these two, and I'll show you how. So the total frequency, if you add 2 plus 6 plus 2 plus 4 plus 4 plus 2, so that's 8, 10, 10, so that's 20. Everyone okay with that part? Quick math. So the relative frequency, I'm going to take the frequency of each of these classes and divide it by the total frequency. Everyone okay with that stuff? Okay, so for this class, we're going to have the frequency of this class over the total frequency, so that's 2 over 20. Everyone good with that? Okay, what would the relative frequency of that class be? Anyone? Crickets. Crickets. It'll be 6 over 20. So if you put that in decimal form, I believe that is 0.30. Similarly for this one, the relative frequency is again 2 over 20. So again, 0.10. So, and then for this one, we have 4 fall within this class. That's 4 over 20 is the relative frequency. So that is 0.20. Similarly for this one, it's the same thing, 4 over 20. Okay, so what if the frequency is 0? What is the relative frequency? Yeah, 0. It's 0 divided by 20, so it's 0. Okay, so similarly, we have here 2 over 20, which equals 0.1 again. And then again, you have 0. So, and then if you want to verify that that is actually correct, what you can do is add up the fractions. So everything is over 20, so you can just add the numerators. So 2 plus 6 is 8, plus 2 is 10, plus 4 is 14, plus 4 is 18, plus 2 is 20. So 20 over 20, which equals 1. So if we add up all the relative frequencies, we should get 1, or 100%. Does that make sense to everyone? Since we exhausted all the data points in our data set, that means we included all of them in our frequency distribution. Therefore, if I add up all the frequencies, I should get, add up all the relative frequencies, I should get 1. Everyone okay with that? Did that confuse you? Okay, cool. So this part will confuse you. Okay, so the cumulative frequency part. So remember, cumulative frequency are used to show how many data values are accumulated up to and including a specific class. So for this first class here, since the frequency is 2, I have no frequency that, oopsies, what in the world did I just do? Okay, so since this is the first class I'm talking about, so how many data values have been accumulated up to 104? How many think? Just 2, yeah. So the cumulative frequency of the first class is just the frequency. So then if I want to find the cumulative frequency of this class up to 108, then what I want to do is add the frequency of the first class to the second class. Does that make sense? The data values accumulated up to a certain point. So the number of data values that are up to 108 degrees is, so I have 6 data values within that class from 105 to 108. And then I also have the class limits below that as well. So the frequency is 2 in that one. So we have 6 plus 2, which equals 8. So what would the cumulative frequency of this class be? Yep, correct. And then this one? Yep. Next. It's another 4. Yep. What about this one? I have 0 here, so what is it? Yeah, 18 again. I added 0 to 18, so I got 18. And then here, I add 2 to 18, so I get 20, 0. Oh, this should be 20 here. Does that make sense why? Because all the data values up to 132, there's 20 data values like that. Because on the previous page, remember, where is it at? I had all of my data points fell up to 128. So the cumulative frequency up to 132 is the total frequency, 20. Does that make sense? Is everyone okay with that? So, cumulative relative frequency. So what do you think that is? So, just like relative frequency was the frequency of any class divided by the total frequency, the cumulative relative frequency is the cumulative frequency of any class divided by the total frequency. Does that make sense? So, this one would be 2 out of 20. What would this next one be? 8 out of 20. The next one, 10 out of 20. 14 out of 20. 18 out of 20. Again, 18 out of 20. 20 out of 20. And again, 20 out of 20. That is one ugly looking one. So, I went through that fast. Did that make sense? Is everyone okay with how I did that? It's just like relative frequency, but I'm using the cumulative frequency. So, last semester cumulative is where people messed up. So, just remember cumulative, it adds upon itself, it accumulates. So, everyone okay with that? Cool beans. So, the next thing we're going to talk about is graphs. So, that was all for section 1.1. Section 2.1. Section 2.2 and 2.3 are all about graphs. So, we're going to be drawing stuff. Don't worry, my drawing sucks too. I had to use a ruler to create my notes. So, The first one we're going to talk about is a histogram. So the histogram is a graph that displays the data by using continuous vertical bars. I don't know what the heck that's supposed to say. Don't worry about that word. As you can tell, I don't really edit the notes. I'm literally given these from one of the head instructors, and we just fill them in as grad students. Because we think it's helpful if we go along with you. Does that make sense? Because some people learn better when we're doing that. So, the histogram is a graph that displays the data by using vertical bars of various heights to represent the frequency of the class. So, since we're making a graph, we need to define what goes on the x and the y axis. So, on the x axis, we have our class boundaries. So remember how I said we have to compute the class boundaries, that way the bars meet at one point, that's why you use them. So, in the y-axis, what do you think goes there? So what are what's up? Correct. So the heights of the bars are the frequencies. It also says right here, vertical bars of various heights to represent the frequencies. The frequency. Also, if you can't read my notes, I'm sorry sometimes. Someone complained that I used someone else's notes from last semester, and yeah, I did. I was lazy. It was my first semester teaching the class, so I just used someone else's. But over winter break, I was bored and created my own and wrote in everything. So whenever you see the pretty notes on Canvas, you can thank me. I was up till 2 a.m. doing that like every night because I had nothing to do. What in the world? Quit turning off. Okay, so note you could plot the relative frequency on the y-axis. So you just take the frequencies divided by 20. That would be the relative frequency on the y-axis. So you can see the book for an example. Oh, does everyone know how to get to the book? You want me to show you? No? I mean, it's pretty easy. All you got to do is go to, hey, does everyone online know how to get to your textbook in case you need to look at it or not? Okay, I got one no and a yes. Okay, so I'll share my screen and show y'all. If I'm being honest, some of your test questions are literally questions from the book. Okay, so what you do, oopsies, wrong thing. Mother, stop. So you go here again. So if your thing isn't connected, that's how you get through Alex through Canvas. You just hit the modules thing and hit the link. Holy cow, I blew it up, I forgot. So here's like your home page. I don't know what the student one looks like, but you literally just click on the textbook and it takes you there. Ta-da. And you just click on whatever chapter you want. Yeah, we're not covering 14 chapters in this class, don't worry. That's way too many. I don't know why they put this in here. This is for seniors. So I don't know why they did that. So now that I've showed you how to do that, let's go back to this. So let's try an example. So using the previous temperature example, draw the histogram. So on the x-axis, we have the class boundaries. On the y-axis, we have the frequency. So how you scale the y-axis really doesn't matter, I guess. So what I did, since I knew that My frequencies for each class, the highest one was 6 and the lowest was 0. I just made it in 2s, so I had 0 there, 2, 4, 6, and 8. So I scaled it by 2. Does that make sense? I don't care how you scale it on the exam unless I tell you how to scale it. So then on the x-axis, we'll go to class boundaries. So we're literally going to take, yes, it did. Sorry, my roommate texted me. So we want to use the class boundaries we found from right here. So we're just going to use these, and we're going to put those on the x-axis. And they do have the same scale because each one has width 4. Everyone okay with that? Okay. So the way I do it, since we don't have like a 0 starting point unless you have like a 0 temperature, I started the histogram here. And I called this point 100.5. So the lowest class boundary. So then I do the next one. So the next class boundary, the upper one, is 104.5. Then I go to 108.5, 112.5, 116.5, 120.5, 124.5, 128.5, and 132.5. Oopsies. So does everyone see where those came from? Literally just these numbers. So I went 100.5, 104.5, 108.5, 112, all the way down to 132. So, and then what we want to do for finding the frequency, so these class boundaries, 100.5 to 104.5, correspond to the class limits of what? So these class boundaries correspond to the class limits of 101 to 104. Does that make sense to everyone? So, and then the frequency of that class is 2. So the height of this bar will be 2. Okay, is everyone okay with that? And we keep doing the same. So for the class boundaries of 104.5 to 108.5, that corresponds to the class limits of 105 to 108, I believe. Yep, 105 to 108. And the number of data points that fall within that class is 6. So the height of our bar will be 6. So note that we overlap these bars. So there's no gap in between these because the class boundary, the upper class boundary of the first one is the same as the lower class boundary of the second. Does that make sense? Did everyone get what I said? Okay, cool. So you can put the frequency on top of the bar if you want. Makes it easier to tell. So then for the next one, 108.5 to 112.5, that corresponds to the class limits of 109 to 112, and the frequency of that one is again 2. So y'all finish up the rest of the histogram, and I'll come around and see if y'all are doing it right. Sound good? People online do the same. Does anyone know anyone that wants to buy a driving iron? It's a golf club. I'm trying to sell it. I can't hit it. Colton, if you know anyone, hit me up. It's a TaylorMade Sim UDI 3-iron. Yeah, these first 2 chapters are very boring. Sorry. Chapter 3 and 4 should be more engaged, I guess you could say. Looks like most of you had got it figured out, so let's do it. So, for the class boundaries of 112 to 116.5, that goes with the class limits of 113 to 116. And the frequency of that class is 4. So this height will be 4. Same for the next one. So for the class limits, for the class boundaries 120.5 to 124, that goes with the class limits 121 to 124. And there were no data points that fell within there. So we don't have a bar with any height. Does that make sense? Because the height is the frequency and there's no frequency. So there's no height. So for 124 to 128.5, that's 125 to 128. And there was 2 points in there. So 2, and we have 0, and we had 0 points in the last one. So that's what it should look like. Everyone got it? I think most of you got it. Cool. So that's the first kind of graph we're going to talk about. There's like 5. I'm sorry. Holy cow. Never mind, there's more than 5. There's like 7 or 8. Don't worry, I will not ask you to do every one on the exam. I usually pick the easiest one. Okay, so let's go on to the next one. So, is everyone okay with making a histogram? Cool. Okay, so the next one we're going to talk about is called a frequency polygon. So, and it's going to be looking weird. So, the frequency polygon, that's obviously what goes here, is a graph that displays the data by using lines to connect the points plotted for the frequencies at the midpoints of the classes. So remember how we talked about how to calculate the midpoint of a class? You add the lower limit to the upper limit and divide by 2. So what goes on the x-axis? So we're plotting these frequencies at the midpoints. So obviously the midpoints are going to go on the x-axis. And what do you think is going to go on the y-axis? What's going on the y-axis in the last one? Yep, frequency. Anyone know a good medication for tooth pain? What? What's up? Okay, cool. Sorry, I can't hear out of those stupid things. I can't wait till this thing's over, so we're just going back to regular. I hate being in a giant classroom and having to wear this thing. I forgot this thing last semester, and I had to teach with a mask. Worst day of my life. I made sure no one was around, and I just took it off. So, okay, so now that we talked about what goes on the x and the y-axis, ooh, people are commenting. Tooth pain was one of the original uses of cocaine. Oof. Nope, no cocaine here. Nope. It may help me lose weight, though. The dad bod is in season. Most people don't think so. So, cloves are good. They're in the spices at Walmart. I actually have cloves at my apartment. Oh, funny thing, I ran into one of my former students at my apartment. Yeah, it was one of the ones I gave a D to, so I felt so bad. I was like, should have came to my class and paid attention. Not my fault. So, back to the good stuff. Good stuff. So, note, just as a histogram, you could also plot the relative frequency on the y-axis to create a relative frequency polygon. So another example is in your book. I have no idea where it's at. I haven't looked. So if you desire to go look, you can look. So let's try an example using the same exact data we just did with the previous one. So on the x-axis, we have the midpoints. Also, you could put like what you're measuring or like what's changing. So how I did it in the one I will post, the completed one, is I put temperature on the x-axis because that's what is being measured. Does that make sense? So, but most people just put class boundaries or midpoint. So you can just put midpoint. Everyone okay with that? Cool. And the y-axis obviously is the frequency. Okay, so now, did we find these midpoints already? I think we did somewhere. Well, no, we did not. So, first thing we want to do is find the midpoints, I guess. So, where was this? Here we are. So, I guess we can put something over here that says midpoint. So I can't fit midpoint on the screen, so we're just going to put mid P. So, remember how to find it? We took the lower limit of the class, we added it to the upper limit, and then we divided by 2. Everyone remember that? That's how we did it. Where was it at? On page 2. So we add the lower and the upper class limit, and we divide by 2. So what would be the class midpoint for the first class? 102.5. So for the next one, we take, so do you know how I found that? 101 plus 104 divided by 2, so that's 205 over 2, which is 102.5. Okay, I'm going to run to the bathroom. Y'all finish those up, and we'll go when we get back. So, did any of you actually do it while I was gone? It is cold out there. Woo! Okay, so for the first one, we found the class midpoint was 102.5. If we take the next one, we want to find the next class midpoint, so that's from 105 to 108. If I add those two, I get 213, and then if I divide it by 2, it's 106.5. Sorry, out of breath. I ran. Okay, does anyone notice anything about this? What's the difference between those two? 4, and what is 4? The class width. So the next one's going to be 110.5, 114.5, 118.5, 122.5, all the way down to 130.5. Okay, is everyone okay with that? So now we're going to use those class midpoints and the frequency. So will you always be yes, Paige, for a frequency polygon? Yes, we use the class midpoints as the x-axis. So that's what we're going to plot there. Will be these. Out of breath. That's what happens when you're out of shape. 10 out of 10 don't recommend. So now that we have those midpoints and we already have the frequencies, so we can make the frequency polygon, and I shall show you how to do that. So just like how I said the last one, there is no real zero for this data. So what I did is I started it a little bit off the edge right here. So I had the first class midpoint of 102.5 was right here. Oh no, what was that one? Yeah, that is that one, my bad. So the first class midpoint, 102.5, then 106.5, 110.5, 114.5, all the way to 130.5. I may have started that too far off the page. Whoops. Okay, after this one, I will show you all some examples of what could be on your homework. That way, if you want to get started on it with the stuff we have done, you can do that. Someone already actually did their homework. Good job. So, again, I'm going to keep the frequency, the y-axis, the scale the same. So I have 2, 4, 6. So now I want to look at the class that has a midpoint. Gosh dang it, why do I keep doing that or knocking into it? So I want to look at the class that has a midpoint of 102.5 and look at its frequency. And that's the class that has the class limits of 101 to 104. So the frequency of that class is 2. So I'm going to put a dot at 2. And also what I'm going to do is, so I start my frequency polygon at 0. You put it just to the left of the first class midpoint. And then we're going to draw a line from 0, this dot, to there. Everyone okay with that? So I'm going to make a line. Okay, so now we're going to look at the midpoint of 106.5 and see what class that corresponds to and what the frequency of that class is. So it corresponds to the class of, which one is it? 105 to 108, and in that class we had a frequency of 6. So we're going to put a dot at 6, and then draw a line to it. Okay, is everyone okay with it so far? I'm going to keep doing the same thing for every midpoint. So, for the next midpoint, 110.5, the frequency of that class is 2. So, I just draw a line down to 2. Why would we put the first dot at 0 if there is no x-axis value paired with it? That's just so we have like a idea of, I don't know, that's just the rule for it, I guess. That's what I've been told, so. Does that make any sense? Yeah. Technically, how I think I did it last semester is I took what would be the class midpoint of the preceding class of 102.5. So I took off that, I took off 4, and then I just made that my 0 point, since there was no data points up to 98.5. Does that make sense? Yeah, it's kind of confusing. So just always remember, plot 0 a little bit before 102 before the first data point, even though there's no data corresponding to that point. Does that make sense? Okay, so for 114.5, the frequency of that class ends up being 4. For 118, it's 4 again. For 122, 0. For 126.5, it's 2. And for 130, it's 0. So then if you connect the dots like this. And that is your frequency polygon. Oh, what'd she say? Oh, I thought I answered that earlier. Yes, so it'll always be the midpoint of the class for a frequency polygon. So, is everyone okay with that? Because if we did include this 0, it looks kind of goofy. So, that's how you make the frequency polygon. You may see it on your homework. You will not see it on the exam, probably. The one you'll see on an exam is a histogram or a bar chart, because they're the two most frequently used ones. So, next. So, both histograms and frequency polygons are used to look at the distribution or shape of the data. So, we specifically look at the shape of the distribution to tell us what type of statistical method to use to analyze the data. So, that is kind of more in advanced classes, so you don't have to worry about what that says. So, here are the most common shapes that we'll discuss in this class. So, if any of you have taken a statistics class in high school or anywhere else, you have probably heard of the bell curve. So the first one we're going to talk about is the bell-shaped distribution. So that looks like this. So I can't draw, so sorry. We're going to try. So does anyone know why it's called the bell-shaped distribution? You can kind of guess why. You draw a curve over it, it looks like a bell. Ta-da. That's why it's called bell-shaped. So, another one we talk about is uniform. And what do you think uniform means? Basically the same frequency across every class, so it's going to look something like this. Maybe it has a little difference, but for the most part, it has the same frequency. that's what uniform looks like. So next, I really never talk about these two. I don't know why the book mentions them. So there is something called J-shaped and reverse J-shaped. So that's J-shaped. Can anyone guess why it's called J-shaped? It looks like a J. That's why. Ta-da. So then reverse J-shaped. What do you think that is? Just literally take that graph and flip it. So it'll look like this. So that's reverse J-shaped. So it's like a reverse J, as in Josh. That's me. Then these two are the ones that I will ask you about, and you should know some stuff about them later. So one is called right skewed. So that's right skewed. So if you draw a curve, rough curve over the data, you will notice there's barely any data points down here compared to over here. So if you draw the curve over here, so the end that has the longest tail is going to be the skew. So if the tail is on the right, it's right skewed. If the tail is on the left, then it's left skewed like this. So now if I draw that, so if I draw a curve over this, roughly, it looks like that. So the tail is to the left. So that's right skewed and left skewed. So does that make sense to anyone? So if you have like an unusually amount of data here and then you have barely any down here, then it's skewed. And whatever way the tail is, whether you have the long tail here, it's right skewed there. And if you have the long tail to the left, it's left tail, left skewed. You could also think of this as positive skewed because it's to the right. And which one do you think that one would be? So if one is positive skewed, the other one has to be negative skewed, correct? Okay, so there's two other ones. Oh, I didn't even talk about this one. I didn't even write down the name. Reverse J-shaped, I talked about that. Okay, so the other two we're going to talk about is bimodal and U-shaped. So does anyone know what the mode is? The mode in a data set is the number that occurs most often. So say you have a data set consisting of just random numbers, and you have, say, 2 7s. Then the mode of that data set is 7, since it occurs the most times in the data set. Does that make sense? Okay. So if it's bimodal, then it will look like this. So does anyone see why it's bimodal? There are two big humps. So this here is a mode, the number that occurs most often. And how do we know it occurs most often? Because the y-axis is the frequency. This is also a mode. So there's two modes in this data set, so we call it bimodal. So if we have more than two modes in our data set, what do you think it's called? Multimodal. So that's bimodal and how it looks. So one of the questions I gave on my exam last semester had a bimodal graph on it, and I asked you to comment on the shape of the distribution. So you could say it's bimodal. So the next one is U-shaped, so it kind of gives itself away by the name. It looks like a U. So if I draw a rough curve over it, it looks kind of like a U. So U-shaped. So we really don't talk about that, or that. What do I want to get for lunch? I am starving. I have not ate. I did not go to bed till like 1 o'clock last night because my roommate would not shut the you-know-what up. He's playing his stupid video game on his computer, and I wanted to go flip him out of his freaking chair. So, is everyone okay with all those shapes? Okay, so no. Where's my blue one? There. No, this. This. And this. Those are the ones I use most often. So, everyone okay with that stuff? Cool. Next. Which one is this? So we'll go over one more graph, and then we're going to get out of here. So, let's go over some of the ones that could be on your homework. That way, if you want to, you can get started on it. So, I literally did the same thing I did last time. I printed a PDF of what you can see on the homework. So, it says, find the class boundaries, the midpoint, and the width. So, you remember how to find the class boundaries, right? You literally take 0.5 off the lower, add 0.5 to the upper. So, what would be the class boundaries for that? Correct. 125.5 and 148.5. Okay, so what is the class midpoint? So you just add the upper and the lower limit and divide by 2. So if I add those two, that'll be 274. And if I divide by 2, that's 137. Okay, so the class width. So some of you would say 148 minus 126, and that's 22. That's close, but that's wrong. So if you're only given one class that has limits, then the way to find the class width is to take the class boundaries. So 148.5 minus 125.5, and that difference will be the class width. So that will be 23. Does that make sense? Because remember how whenever we did the class limits, we added the class width to the lower number, the lower limit. So if I take 23 and add it to 126, that's 149. And then if I take off 1 to find the upper limit of this one, it's 148. So then literally the same thing for number 2. So it says, it's actually multiple choice. Find the class boundaries, midpoint, and width for each class. So let's see if someone gets the answer right. This one is decimals, so it's a little bit different. So since we're to 1 decimal place, instead of subtracting off 0.5, I'm going to subtract off 0.05 and then add 0.05. So if I do that, I end up with, all of these three have the right class boundaries. So the midpoint, I want to take 35.3 and add 40.5. That will be 75.8. If I divide by 2, that's 37.9. So the width would be 40.55 minus 35.25, which is equal to 5.3. So the answer is B. So does everyone think they can do that on their homework? Cool. What else is there? It also has you make frequency distributions and complete tables. So know how to do that. So then it literally gives you, it says, the frequency distribution shown is constructed incorrectly. State the reason why. So let's look. So what do you think, which one it is, and tell me why? It's the first one up top. You only got 3 choices. So let's look at something. So the class width here. So we take the lower limit of this class and subtract the lower limit of the previous class. So the class width is 5. I do the same here. And these two, class width is 5. If I subtract these two, 42, 38, the class width is 4. So remember, the class width has to be the same over every class. So the problem is the class width is not uniform. Does that make sense? The class width is not the same across all classes. That's what it means by not uniform. So question 4 has the same problem. The class width here is 5, 5, 4. So again, the class width is not uniform. So question 5, it has a survey, and it's given responses here. So the responses are A, M, H, and S. No idea what it's about. Oh, trust. Oh, it's about if you trust in what you read on the internet. Half the crap is bull crap. So then from that, it has you create a frequency distribution. So you literally have to go through and see how many people answered A, how many people answered M, how many people answered H, and how many people answered S. Do that, put the total in, and you're done with that question. So this one here is a class width question. Holy cow. So once you get to question 6, they have 5 parts. Sorry. I think. Holy majoli. Why do they make your homework so long? So first thing you do, find the class width. So you take the range and divide it by the number of classes, and it gives you the number of classes, 9. So you can find that. So let's do that real quick and see if we can find what the thing is. So the highest is 105. So range R equals 105 minus the lowest one, which is, I see 54. It's the lowest, minus 54. So the range is 51. So then the class width is equal to 51 over 9, which is roughly 5 point something. So if it's 5 point something, we round up to 6. So the class width is 6. So that's how you do that stuff. And then it's just basically what we've done. So if you want, you can get started on your homework. It basically is kind of the same stuff as we did in the notes. So since we didn't finish most of this, your homework will probably be due a little bit later than what it shows on Alex. I don't know when yet, but I'll change it whenever I figure out when we want it due. So if y'all have any questions, I have office hours. I changed the office hours in the syllabus. I thought 2 hours was too long, so I made it 1 hour from 1 to 2 on Tuesday, Thursday, Friday. If y'all have any questions, let me know. See y'all Thursday.